Well, first I want to thank you all for being here. It's been really great so far. And I'm going to give you a different view, like Alex said, of the way, of user research with AI. Like the last speaker, I also had to go through several rounds of approval to be here, so I too will be referencing my speaker notes. Cool. Whoa, I did it too. All right. Here's my title slide, the role of user research in AV development. Okay, so at the heart of what I'm going to talk to you about today is this question. How can user research play a role in AI engineering? Now, I know that these two worlds probably seem like they're worlds apart, but they're actually interconnected. There's been a lot of excitement and anxiety in the user research community around the role of AI, but I think there's one thing that we often fail to talk about, and that's how user research can be integral to the very creation of AI. Today, I'm going to make the case for how we as user researchers can play a pivotal role not only in defining the end user experience, but in the very engineering and development process. Okay, so during my time today with you, I hope you'll be able to take away 3 things. The first one is how user research supports AV development at Cruise. So we'll talk a little bit about the AV development process and where user research fits in. Then we'll go through 3 examples of what this can look like in practice. And then finally, I hope to leave you with a challenge that I hope will kind of spark some thinking about what this means for you. But before we get into all that, let me introduce myself a little bit more. I'm Lisa, and I'm a user researcher at Cruise. So for those of you who don't know, Cruise is one of the companies that is pioneering self-driving technology. This is a totally new technology that we're bringing to the world for the first time. I've been at Cruise for about 2.5 years, and most of the research, virtually all of the research that I've done has been focused on the people, workflows, and specialized tools that we need to build to make these AVs a reality. So when I say that, you can imagine that there's not a lot of tooling that actually supports AV development that already exists. We have to develop that virtually all in-house. So this isn't my first time working at the intersection of AI and human experience, though. Before that, I was at IDEO, where I worked at, I researched and prototyped AI products that had the ability to enhance human lives. And obviously one of my passions is taking a human-centered approach to building new tech products. And that's why I'm very interested in the space of how user research can support AI engineering. Now, I don't know how much you guys know about self-driving cars, but we're going to talk a little bit about what the actual technology in self-driving cars is. So the AI that powers an AV is not one monolithic model. It's actually made up of many different models that all do different things. At the highest level, we call this the AV stack. And it's made up of models for perception, which help the AV see and understand what's around it, prediction, which kind of predicts the behavior of other actors on the road, and planning, which makes decisions about what to do next based on the output of perception and prediction. All of this is extremely complex. These models, they're not just 3, there are many perception models, many prediction models, many planning models. It's extremely complex, but all of that complexity is built and managed by human beings. There's a lot of work that goes in to building the tools that they need to succeed and making sure that they have the right information to make decisions. Okay, so that was an introduction to Cruise. Before we get into what user research that I've done has looked like. Let's take a step back and think about what we might think of as a typical way that user research can show up for AI. In a typical view, you would usually see the AI as a black box. In fact, we started talking about that earlier today. And we would focus more on the interface between the AI and humans. So how are people using it? How should they integrate it into their workflow? Is it usable? These are the kinds of questions that we would ask. But what I would argue is this specialized AI is not actually a black box. Even though it seems like that sometimes, it's really not. So how can we expand our thinking beyond the black box? So to do that, I think we have to understand a little bit more about how the development process actually works. The development process looks something more like this. And right now what I'll do is kind of like walk you through this process with the example of, let's say a behavior was observed, like a weird behavior around a bicyclist was observed. Okay, so the first thing that needs to happen is engineers and developers need to understand the problem. This means that they don't just have to understand what went wrong or what we saw. They have to understand like what about the AV stack caused that problem. So in the case of a weird behavior around a bicyclist, was it a problem with how the model perceived the bicyclist, predicted its behavior, or a problem with how the model was actually making decisions around what to do next? It's not simple or straightforward for people to actually diagnose the root cause of issues. The next things that happen is that engineers prepare to do their work. So here they might be, to train their models, they would actually need like thousands of similar scenarios. And they need specialized tools to kind of like be able to identify those. Additionally, here's where they would be coming up with their plan for testing it. So AVs are actually tested in simulation before code changes roll out on the road. So at this point, engineers need to come up with their test suites and actually create them. So here they're creating suites of many different simulation tests that they're going to use later. Next, they move into a part where they actually like train their models, and here they may be looking at many different parameters and data combinations to find out which one works best. And then we go into testing, and this is where engineers will be running all of their simulated tests and evaluating them. At this point, they need to test for improvement like we talked about, but they also need to make sure that they haven't made anything, like inadvertently made anything worse. So in the example of the bicyclist, if they improved the perception of bicyclists, maybe by adding an understanding of hand gestures, they need to make sure that that hasn't inadvertently caused a regression in the way that the AV reacts to pedestrians. So this analysis can get extremely complex. And then finally, it can go out in the real world. Now, I don't know if any of you are thinking, why am I learning about AV development at a user research conference? I hope not. I hope this point lands. The end user is only involved at this phase at the end. But what happens what about all these other phases? What about the people involved there? What do they need? Let's continue this train of thought. How does an AV know what good looks like? So how does it judge what a good behavior is? How does it solve the right problems? How does it select them? How does it figure out what the solution is? And how does it know if it's actually improving? If these questions seem a little silly, it's because they are. Obviously, an AV is not doing this by itself. People are in the loop making these decisions. So all this points back to the fact that user research has a larger role to play here than just thinking about the end user and their interactions with the AI. As user researchers, we not only help understand the end user, we answer questions that are integral to building the right tools and metrics by understanding all user perspectives, including developers and engineers. Ultimately, what this enables is a connection between the developers back to the end user. Cool. All right. Now I'd like you all to do a thought experiment with me. Let's take a moment to imagine a world where consideration of humans is somehow entirely absent from the AV development process. In this alternate reality, AVs are designed and updated solely based on technical specifications without recognizing the significance of addressing the end user experience needs or the needs of the engineers who create and maintain the models. What would an AV developed in that world be like? Now what we're going to do is we're going to do this thought experiment in 3 different scenarios, talk about what an AV in that world would look like, and then talk about how user research helps remedy that situation in reality. Our first question was, how does an AV know what good looks like? Which I have put as, how does an AV know what good behavior looks like? So, how does an AV know what a good behavior around a bicyclist is? For example, so in this alternate reality, AVs are actually built without any insights from riders. The vehicles in this alternate reality are impeccably safe. They're super safe. But there's one problem, and that is that riders find them very uncomfortable and also scary. So they're very safe, but no one wants to ride in them. So in this world, we have a product that is technically very good, but no one wants to use it. How can we remedy that situation? So the way that we can remedy this situation is to enable understanding of the AV behavior in terms of the rider experience. So this involves understanding the feelings and sentiments of riders and then using that to create something that engineers can actually use to measure performance. Okay, so let's shift back to actual reality for a second. A question that you might ask here would be, what do riders feel is a comfortable trip? So in one study that I ran, we had people take rides in AVs while they filled out surveys about events that they found comfortable or uncomfortable. At the end of the ride, they gave a star rating for their overall experience. So this survey and they also did a follow-on interview afterwards. But this wait a second, sorry. Yeah, the data from the survey was used to understand the types of behaviors that were most unacceptable to riders. And one interesting thing about this is we were also able to take the survey data and connect it back to the acceleration data from the AV to understand what thresholds of accelerations riders felt comfortable or were comfortable or uncomfortable. So studies like this also can be used to create metrics that can be used to measure AV performance even when someone isn't in the vehicle. So this allows us to create metrics based on the user experience that we can use in the engineering process. Okay, so our next question was around identifying the right problems and coming up with solutions. Back in our alternate reality, developers randomly select problems to solve because it is very difficult to find the right information about an event to diagnose it. It's very difficult to figure out what a bad event is, and it's just very difficult to prioritize. This leads to a lot of guessing about what should actually be improved. So in this world, AVs are very good at things that nobody cares about. In fact, they might be very good at navigating complex obstacle courses, but they're not very good at tasks that significantly impact the customer experience. In fact, these AVs can't pick a correct drop-off location for passengers. Again, what do we need to do to remedy this situation? There are actually like a few different needs in this situation. So one of the first things we need is to kind of like understand what is an event that we might want to diagnose. And we already learned about how user research can help us create metrics to identify those. The second thing we need to do is really help developers efficiently and accurately look into those events and understand what about the AV stack they actually have to fix. The third thing is also enabling effective prioritization of different solutions and root causes. Okay, so if we shift our focus in the real world, user research helps with this by kind of understanding the tasks, workflows, and information needs of people who actually do diagnosis. So one study I did actually mapped out the entire diagnosis process for one kind of event, all the way from the event happening to the solution getting prioritized. And that process, when you map out that process, you can look at the decision points and the information needs. Now, what we learned is that process actually spanned many different individuals across different teams, and they all had the same needs for consolidated and traceable information. So these findings and findings from other studies were combined to create a new tool that enabled effective tracking of a diagnosis event across teams, which helps with reducing redundant work and also with prioritization. And our last question was this question about how does an AV know that code changes will actually improve what happens on the road. Okay, so we're back in our alternate reality one last time. In this world, AVs receive code changes with limited testing and incomplete analysis because engineers don't have tools that they need to accurately assess the impact of changes. These engineers sometimes achieve improvements, but they inadvertently introduce new errors. Making progress is difficult, and even when engineers improve one thing, there may be something that shows up later, and we don't know until something actually happens on the road. Again, to help with this situation, we need to understand the needs of engineers around performing complex analysis in different scenarios with simulated tests and metrics. One thing about this is this does become more complex over time because the complexity of this AV stack actually increases. And again, in the real world, user research can help with this. So we actually do a lot of work on testing, and there's a few different things that you can track about it. You can use surveys to understand engineer sentiment towards their workflows and metrics over time, so you can keep a continuous pulse on that. There are also workflow studies and studies where we have people, basically looking at the needs that people have as they are doing this complex analysis. So things like this can come together to identify, I guess one of the needs we identified is as the AV stack grows, people were kind of doing more complex analysis with more model candidates and needed more flexible analysis tools that would enable better aggregation and slicing and dicing between these different, variables that they were changing. Cool. So thanks for going to the alternate world with me. to leave you, before I leave you, I thought I would give you the TLDR on this. And since you're all researchers, I thought I would do it in a way we can all relate to, with key insights and recommendations. So the key insight here is that user research can play a pivotal role in AI because it allows us to understand all users that are involved in a process, not just the ones at the end. I think this is really important because we do need to make sure that the people who are building these are able to make effective decisions. And so obviously we need to build tooling to support that. And here are some recommendations for you. The first thing is, if you're interested, I would recommend broadening your scope. You can look beyond the interface with the end user for AI systems. I don't mean you need to go and learn about how the models work, but it's more about you can learn more about the development process because people are involved in that. And the second one is get involved. Learn more about how AI is created, particularly by fostering collaborations with engineers who actually build it. All right, thank you.